What is up, Flutter devs? In the previous video where we were porting processing over to Flutter, we converted our entire display system from the standard Flutter pipeline over to a bitmap-based representation. And the reason we did that was to prepare ourselves for the ability to both query and mutate bitmap data or pixel data in the future. We still kind of need one more step to open up that possibility, and that's the ability to load and display bitmap images. And the reason we want that ability is because if we can load and display a bitmap image, it will make it much easier for us to make sure or to verify that our actual bitmap querying and mutating in the future videos actually works the way we think. So today we're going to create that ability both to load an image from assets as well as display that image in our processing sketch. Let's go take a look and get started. Here we are back at the standard processing API spec, and we will begin today by taking a look at loadImage right here, loadImage, which I already have open. In terms of what we want to be able to do in processing, you'll see here that we can call loadImage with some kind of path, and then we can paint or display that image in our sketch by calling this image function. So both of these kind of go together hand in hand. It doesn't make a lot of sense to have one without the other, so we're going to implement both at the same time. Now, one decision that we've kind of already made this decision, but we're going to continue with this decision, which is we are not going anytime soon, we're not going to create our own version of pimage. Pimage as in processing image. Flutter and the Dart UI package already give us a construct called image, and if we want Flutter to display an image on our behalf, it has to be of that type. So for the time being, all the stuff that we're going to do with images are going to use the standard built-in image class. If at some point in the future it makes sense for us to abstract that, generalize it, or introduce a different API called pimage, we can look at that possibility, but it's not going to give us any advantages right now. That would just create complexity, so that we're not going to do that. We're going to implement loadImage here so that it returns a standard Dart/Flutter image, which we can then pass to this image function to display within a sketch. Let's figure out how we're going to do that. First, let's go declare this method, and let's see what we need to be able to accept here. So loadImage, we're not going to worry about extension. I think we'll just take a file path instead of this name and extension thing. We'll come in here to the core implementation code for Flutter processing. I've already provided us with an area to implement these methods under image and specifically the subcategory loading and displaying. What we want here is a method called loadImage, and we're going to take a file path. But what do we return? Well, we might say that we return an image. And by the way, notice there are two different images here. We don't want the image widget, we want the Dart UI image. So that's the one we're going to select. But let's also make sure we got the correct one. Okay, we're in painting.dart, so that is the correct one. That's the Dart UI image, not the widget. But here's the thing. We cannot load an image synchronously. It's not immediate, and in Dart, if something is not immediate, it's going to be asynchronous. So what we're returning is not really an image, but a future that will eventually return an image. And to make the implementation of this method simpler, we're going to declare it async, which gives us the await keyword inside of this method. Now, the fact that we return a future is not ideal when it comes to processing developers using Flutter processing, because in the standard processing implementation, there's a whole bunch, everything's synchronous. There are no callbacks. I guess there's one call that I can think of that's asynchronous in processing, but that's about it. Java makes it very easy to block the thread. which for application development is not great. We're always trying to avoid blocking threads, which is why Dart and Flutter make it so easy to do asynchronous behavior. But if all you want to do is write down a series of painting operations, it can be nice to know that everything is going to execute in exactly the order you're expecting, and it will take however long it takes, but by the end, everything's done. We don't have that luxury in Dart, so we're going to have to just deal with the fact that when you invoke loadImage, you're going to need to use the await keyword. But now comes the interesting question of how exactly we load images and where we load them from. So the first thing is, where do we load them from? We're going to make some adjustments to this later, but for now, we're going to use what is called the root bundle. Let me show you very quickly what that is. First, it's important to understand what an asset bundle is. An asset bundle is a generic interface for loading assets, including images. I say it's generic because you could implement your own asset bundle. You could create one that returns fake data or returns asset data from a different location. You'll see over here is the API. We have load string, load structured data. These are just generic asset loading capabilities that an asset bundle will provide. But then there is something called the root bundle. Notice the lowercase r. This is not a class. This is essentially a variable or a property, a global variable or property that is available everywhere within your application. Here it says the root bundle contains the resources that were packaged with the application when it was built. To add resources to the root bundle for your application, add them to the assets subsection of the Flutter section of your pub spec. I'm sure any of you who have developed any Flutter apps at all, you're used to having this assets category or whatever that's called in pub spec, but the assets section within your pub spec, and then you list individual images, or you might list entire directories there. But behind the scenes, the way that these assets appear on your screen is that somebody somewhere has to grab the root bundle and load those assets from it, which is probably being done by the image provider that's sitting inside of the image widgets that you use. So you don't see it and you don't know about it, but now we need to see it and we need to know about it. So right here, I've accessed the root bundle, and we can say root bundle dot load. Notice that, so we give it it says key, but what key really means in this case is path, file path. And it's going to return us a future of byte data. So it's not going to return an image to us. It's going to give us just essentially a list of bytes or a reference to a list of bytes. For the key, we're going to pass the file path right in, and we'll say image data equals await. That's why I made this async, so we can use the await keyword, and by the time we get to the next line, we definitely have the image data. But this is just data. We know it's an image, but it's just data right now. So what do? That brings us to the next part of the Flutter API, which is image descriptor. Now, there's going to be an intermediate step, I think, here, but an image descriptor, well, maybe not. Image descriptor, we will pass it a buffer of data. Now, specifically, it wants an immutable buffer, and I'm sure that the underlying reason for the immutable buffer is to make sure that no data changes between when you create the descriptor and when the data is decoded. We can also pass in the width and the height. We can pass in the number of bytes per row in the image, but that can be inferred from the width, and then we're going to give the pixel format. So let's instantiate one of these image descriptors. The first thing is this immutable buffer. So we have immutable buffer from uint8 list. That's our only option for how to create one of these things. And notice that this call is asynchronous as well. It might take some time. It gives us a future. that will return an immutable buffer. So one thing at a time, from uint8 list, where are we going to get this list? Well, we're going to say image data dot buffer dot as uint8 list. This now, we've correctly invoked the function, although actually this image data might be optional. No, okay, never mind. So we've invoked the method, but what it returns to us is a future. We want the actual immutable buffer, so we will say await. Now we get back the immutable buffer and we pass it in as the first argument to this raw constructor for image descriptor. With this, we may actually want to take in the width and the height from the file path. Or actually, perhaps it's an image. Actually, it's a good question where we get the width from, because image data doesn't actually know it's an image. And let's see what happens if those, I guess those are going to be required. Yeah, they're going to be required. Well, pixel format we can hopefully fill in, and then we'll go back and deal with this width and height. So we expect, I guess we don't technically know the encoding here, but I think we can assume that it's RGBA, which is a pretty standard order of pixels or of color data. BGRA, I think, is less common. So we'll go with the RGBA, and the 8888888 here means that there's 1 byte per value, 8 bits. 8 bits for red, 8 bits for green, 8 bits for blue, 8 bits for alpha. But now there's this question of the width and the height. How can we get that? And I don't know the answer to that off the top of my head. We might have to do a little bit of digging here. Now, let me see if I can find a place that does this. So there's a global function called instantiate image codec, and we're essentially implementing that ourselves. That takes a target width and height, but let's see. So here's the immutable buffer, image descriptor, or this says encoded. So maybe that's what we want. Let's try that and see what happens. So going back to our code, yeah, so instead of image descriptor.raw, let's say encoded. Let's get rid of that stuff. And okay, let's see if that gives us what we expect. That's our image descriptor. And then actually what we want is not really an image descriptor. What we want is a codec, which we can obtain by calling, is this also asynchronous here? Yes, it is. So we have to await again. So we await here. So we need to await to create the descriptor, but then with the descriptor, we want to instantiate a codec. And for right now, we don't have a target width or height, but that should be fine. And we're going to await that. So we're awaiting a lot of things here, but at the end of the day, what we want is this codec, because we then say codec dot get next frame. Now, why is it called a frame? Well, this image or this codec concept also supports animations. Animations have multiple frames. It might even support some concept of video. I'm not sure, but the point is there can be multiple frames in theory. Our image only has 1 frame, so we just call get next frame. We await that, and then we access its image. So again, let's run through the steps that we're taking here. The bundle knows how to access the asset. So we tell it, here's the asset file path we care about. We tell the bundle to load all of the byte data out of that asset, which we have here. We call it image data. We take that image data, we convert it to a uint8 list, an unsigned integer list, where each integer is represented by 8 bits. We then take that uint8 list and we create an immutable buffer, which is essentially we're just going to copy it over to a different same data structure, but this one's immutable. This buffer can't be changed. And then we create this image descriptor. And the only reason we create the image descriptor around that data is so that we can get this thing called a codec. And the codec, from our perspective, is what actually does the work of decoding a frame of bitmap data, and then we access that data with this image property. This should be sufficient for loadImage, but we don't have any way to know if this is working without the function or method in this case to draw an image. So let's define that as well. It's called image. Let's go see what parameters it takes. It takes the X and the Y. In our case, for now, the X and Y are going to represent the top left corner. There's something else. I don't know if it's referenced here. Here it is. Image mode. You can interpret the X and Y offset in different ways, like top left or center or all four corners or something like that. Right now, we're not worried about that. We're going to take the X and the Y, and that's going to be the top left corner of where we draw the image. Then there's a width and a height. For us, we're going to take in an offset, and we're going to take in a size. We're going to require the image. Then we're going to require, actually, I guess we don't need to require the offset. We can say the offset is optional, and we will call that the origin. And then I said we want a size, which is the display size. That's also optional. If you don't provide the display size, we're going to give you the natural size. But actually, for now, we're not even going to honor the display size. So we're going to say to do implement display size support. It should be there. Eventually, it needs to be there. But I don't want to deal with how to actually accomplish resizing the image right now. Instead, we're just going to say canvas.drawImage. This is why we're not using a custom image class. We need to tell the canvas to draw the image, but the canvas only understands the traditional image class. So draw image, we pass in the image, we pass in origin, and then we can just pass in a new paint. This paint, for as far as we're concerned, doesn't do anything. It just needs to be there. Now, origin, I'm actually not going to make that optional. I'm just going to give it a default, which is offset.0. So by default, we paint to the top left corner. Now, that, in theory, is all it should take to paint an image after we load the image. So let's go find out if that actually works. I already have the example app running here. This is just an empty canvas for the most part. I've already created an assets directory and put it in the pubspec file. So that should be done for us in the example app. And I have these couple of assets here, audio-mixer and coffee. So I think we should be able to load those images and paint them. Let's find out. I'll open up main.dart. One thing I'm going to do is remove all of this mouse-related functionality because that's just wasting cycles. Now, the image we need to hold on to across frames. So I'm going to come up here into this state object, and we're going to have an image, and we're going to say loaded image. That may or may not exist. In setup, I'm going to declare it asynchronous, meaning setup will not finish until our asynchronous operations are done. I will say loaded image equals s.loadImage. This is our method now. And I'm going to say assets/audio-mixer.png. And we need to await this. Okay. Also, something that happens a lot here, if you don't give a namespace to the Dart UI package, there's a naming conflict. So we actually have to explicitly hide the image widget. Otherwise, Flutter thinks you're talking about the material image widget and not the Dart UI image bitmap class. Let's see, why is it? Oh, and we need to actually import Dart UI. So now all of the compiler issues are gone. In setup is async, and we load the image right here. I'm not going to say that this is nullable. I'm going to say that it's initialized later, and then once it's initialized, it's always there, so we don't have to keep checking it in draw. Now, in theory, if we've done everything appropriately, we can say s.image loaded image, and that should just draw it at the top left corner. Let's see what happens. Nope, something blew up here. Loaded image has not been initialized. Let's do a hot restart, maybe. I wonder if maybe in the implementation for setup, we're not waiting. Okay. I may have done that in a different branch and not done it here. So let's go see where we're actually running the sketch. All right, so we're drawing a frame and we're just calling setup, and then we're immediately calling draw, and we don't want to do that. Here's what we're going to do. We're going to say, we're going to set the canvas, that's fine. And then we're going to say await widget.sketch.doSetup. And then we're going to say await widget.sketch.onDraw. Now, neither of those are asynchronous right now, so let's come down here. We're going to make you async, future void. And this is the private version of setup. We need to make sure that we await the public version of setup. And that means setup here also needs to be, I guess we can actually just return that. Okay, so we have some cascading changes here. We need to change the callback as well to be asynchronous. But while we're down here, let's make onDraw asynchronous. And let's await the draw call, which means that draw needs to be asynchronous. And now once again, actually, we don't need to make it async. We can just return a future from the callback. So I said the callbacks need to be async as well. Okay. And then up here, this needs to be asynchronous. We're going to have to probably make a number of changes to get this asynchronous behavior in here. All right, we will say await, because if the callback doesn't exist, it's going to complain. But if so there may not be a future returned, but if we await, then that issue is already handled. So whether or not the callback exists, this await will give us the behavior we want. All right, and then doDrawFrame, which I think we created in the last video, that is invoked right here. There may be a time where onTick needs to be asynchronous itself, but in this case, it doesn't, because nothing ever waits on onTick to complete. So it doesn't matter that it takes a while, but doDrawFrame will not finish immediately. Now, a bunch of red stuff has appeared over here on the left. These are other places where we need to make those callbacks asynchronous. So here we make setup async, we make draw async. In our purple rain exercise, we make setup async, we make draw async. And we need to make, let's see, in main, same thing. And I'm going to need to change every single test. Let's see if I can somehow generalize this. Say replace, 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 replace. Okay, it's one file done. Okay, another file done. We don't want to replace the key events. Those are not asynchronous, at least not for now. All right, it's another file done. Another file done. Okay, that one's done. And that should be the last one. Now back in main, hopefully this async right here is respected. Let's do a hot restart. Hey, there's the image. Here's the actual image. It's larger than the canvas, so it's been cropped, and that looks like it's the correct top left corner. So the top left corner is at 0, 0, and then the rest of it's cropped. Let's see what happens if we provide a different offset. Let's set the origin to 100, 200. Okay. I assume that's 100, 200. Looks close enough to me. So what we've done here again is we have loaded this image's data from using the root bundle. We loaded the image data. We converted that data into a list of unsigned 8-bit integers, which we then made immutable so they cannot be changed, stuck them into this image descriptor thing, which produced a codec, which decoded the very first frame of the image, and then we grabbed this image reference. We then passed that image reference to the image method with a given offset, and the canvas draws the image. Now, I would like a test for this. We've verified that it works for real. I would like a test. And there's going to be a little bit of a complication in doing that, but let's go see what we can do. So I said that image was the main category here. So test, new package, image. And then within image, let's see, are we doing subdirectories or are we just doing names? We're just doing names. So within image, we're going to create a file called loading and displaying. This is where we will write our test. Group image, group loading and displaying. And then this will need to be a widgets test. Now, what's the problem here? What's the difficulty that we're going to run into? When we run this test, there is no pub/spec file, there is no application, and therefore there is no direct access to assets. Accessing the root bundle will not work in this test. But let's go ahead and let's try to write the test. Let's watch it blow up on us, and then we'll kind of try to debug our way through it. So we need to pump a UI with a processing sketch that wants to load an image. We essentially want this. But now, do I have a material app set up? It's been a little while since I've written some of these tests, and now I'm forgetting how we set up the top level. So we're just pumping processing right in here, huh? Okay, we'll see how that works out. I'll just copy this. We'll come over here to main. We'll grab loadImage, set up async, load the image. And then in draw, we'll copy this over to paint the image. We'll get rid of that origin. We'll let it be at 0, 0, and we'll just paint the loaded image. Now I have this assets directory inside of test, and I've resized these two images to be 100 by 100 so that they fit exactly within the standard 100 by 100 processing canvas size. So we'll go with the space image this time. The space image looks like this. We'll see what we get on the other side whenever it works. But in theory, if it weren't for the bundle problem that I mentioned, we should be able to run this test. We actually still need the golden part here, which reminds me, this isn't test widgets, is it? It is test goldens. And again, to make sure that I don't do something silly, I'll just copy this line directly. And this is image, loading and display, example 1. So in theory, this would load up the one image that I just showed you. It would take up the entire 100 by 100 canvas, and that would paint to a golden file. But that's not going to work. It might not work for multiple reasons, but it definitely won't work for at least one reason. So let's just see this thing start to fail. Say Flutter test image. Yeah, that guy right there. Real quick, let me also say s.noLoop. Okay, failed. Let's see what happened. Unable to load asset. Fair enough. I'm kind of surprised that it even tried. Just out of curiosity, since we're running this from the root, let's see what happens if we say test/assets. I still don't expect that to work, but maybe I'll be surprised. Nope. Okay. There are two changes that I think we're going to have to make here. The first one is that we can't just automatically use the root bundle. Let's come back here to our implementation. This root bundle here, not going to work. we need the root bundle to be set on the sketch. So let's go to where the canvas, for example, is set. Let's draw a frame. I want to see where we set some of the more high level things. Let's see, where would it make sense? We're going to obtain the bundle from the widget tree. We're going to go ask an ancestor to give us the bundle. And I'm trying to think at what the most appropriate place is to do that. I think probably did change dependencies is what's going to make sense. Did change dependencies is called whenever you depend on something higher up in the widget tree that has changed. I believe it's also automatically invoked right after a init state all the time, though I could be wrong about that. But I think what we want to say here is something like widget.sketch.assetBundle equals default asset bundle, maybe? Nope. Let's go see what the API tells us. Well, there is a default asset bundle. Okay, that was right. It just auto-completed to the wrong thing. So we want default asset bundle dot of. We'll pass our context, and that will give us back whatever asset bundle is being used by essentially the rest of Flutter in this case, which will be the root bundle. But the point is, by setting it here, it doesn't have to be the root bundle. Okay, so let's go create that property on Sketch, trying to see if there's some other property where it makes sense to stick that in a similar place. Actually, as I did with the other properties, let's make it private because we don't need anything from the outside messing with that. Let's go down here. Canvas, size, fill paint, all this stuff. Do we have any area with more global related properties where we can stick this? I think this probably makes sense as a location here. Let's say we want an asset bundle, and we're going to call it asset bundle. In do setup, we are going to assert that asset bundle is not null. So this is part of our contract now. We expect that whoever uses this sketch always gives us an asset bundle before calling do setup. And if we're in debug mode at least, and we haven't set it, this will blow up and it will tell us that we're missing the asset bundle. Now down here in loadImage, see here root bundle, that's going away and we're going to say asset bundle. And we are going to pretend that it definitely exists because if it doesn't exist, it should have already broken much earlier than this in the process. Save that. Let's go to run. Let's go to hot restart. Well, our image is still there. Let's see what's going on here. Okay, so it is null for some reason. Why is it null? Oh, I wonder if we're calling do setup even before did change dependencies runs. Let's go find out. That versus do draw frame. Save that. Do a hot restart. Well, it set the asset bundle right there unless the asset bundle itself was null. Well, okay, let's go check that. Nope, there's the asset bundle right there. Yeah. So it appears that we have set the asset bundle. Then we run setup, and yet there's this. Now maybe this exception is still being, maybe the exception isn't printing until later. Let's just say do setup bundle asset bundle. Well, do setup, not null, not null, not null. Oh, somehow it becomes null later. Okay. Did update widget. I think that whatever the hot restart life cycle is, I think it's recreating the sketch a second time, just doing it very quickly. And when it replaces the sketch in the widget, here in did update widget, we are not replacing this dependency. And I don't know if did update widget is going to blow up when we do this or not. Let's do a hot restart. Okay, no more exceptions, and there's the image. So I think that was the issue. The issue is that hot restart, it creates the widget with the sketch, and then it throws out the sketch and creates a different sketch. That might be our fault, or that might just be Flutter's order of operations, but regardless, we need to be able to handle that. And so we do. So let's remove these print statements that are no longer needed. Now that doesn't solve our problem, that just gives us an opportunity to solve our problem. If we come back to this test and let's prove this to ourselves, let's prove that the test still doesn't work. Okay, unable to load asset, fine. Here's what we need to do. We need to surround our processing widget with a default asset bundle widget. And it wants an asset bundle. And we want, actually, I guess we'll make this a class, test asset bundle. We need to define this. This may have use in all sorts of different tests for us. So we're going to come down here to test infrastructure and implement that. I think evict we can probably ignore because this is a very short, these tests are going to be very short-lived. I don't think we need to worry about caching stuff. I'm also, for now, I'm not going to worry about load string or structured data. If we make this method work in a test, this load method, then we should be good. What do we want to do here? We know that this key is actually a file path. And I will say specifically that file path is relative to the test directory. That's how we will interpret it. Say file equals file what does it want? A path? Let's see. Dart.io wants a string path. Okay. And I think I can just say test file path like this. I'm expecting that this method is run from the, so we run our test from the root of this package. And so test / some path should be a path under test. And actually I'll put assets there as well. Let's force this into the assets directory. And so this is really a file name. Now, assuming that correctly locates the asset, let's see what we can do with file here. So we can open it synchronously, open it asynchronously. Can we read the data out of it? We can get a list of integers as a stream, or we can read it as bytes. So that's a uint8 list. We can probably just wrap that in a byte data. So let's say read as bytes, and that's asynchronous. And let's see, file data. What can we do in here? Anything? Trying to see if it has some kind of byte data conversion. Okay, byte data. Sublist view or view. So we can just give it a buffer, a byte buffer. Let's see what we have for byte buffer. Byte buffer. That's an abstract class. So you can turn a buffer into a uint8 list. Okay, well, what's the quick way to turn a uint8 list into a buffer? I'm sure there's some kind of simple way to do that. Oops. What was that? Darn it. No, that's a different kind of list. Unmodifiable byte buffer view, which takes in a byte buffer. Well, okay, folks, how do I get a byte buffer? Oh, the list actually exposes something called a buffer. Where were we? File data dot buffer. Should have remembered that. Okay. Maybe that'll work. Maybe it won't. Let's find out. We're going to come back here to our test. And let's see, did I do this in the wrong test? I did this in the wrong test. We want it in this test. Default app or asset bundle. And we need to import this guy. And now you see that what happens is every widget below this level, when they look up the tree to get the bundle, they're going to get our test bundle. Uh-oh, and what's this complaining about now? Do we have multiple types of images in here again? Why is Cupertino in here? Okay, naming conflicts dealt with. So let's see what happens now. Nope. Let's see. No such file. Oh, test assets. Probably don't need that subpath there. And I also need to say test update goldens. Okay, well, it didn't blow up. Let's see what we have under image. Goldens. Darn it. Okay, it didn't paint. So let's see, what are the possible places where that went wrong? What if we say await tester pump and set? Well, actually, that should already be happening on our behalf. So that probably isn't the issue. Let's see. Nope, that's not the problem. All right. Well, let's say here we are rendering the golden test. And here we are starting to load image. Does file exist? File data length. And let's see if those print statements show us anything of use. We're rendering the test before we finish loading the image. Now this is async and it returns a future, and we are awaiting read as bytes. This isn't async, no, it's a factory, so that should be fine. Let me remove that synchronous method there. Okay, so for some reason, I guess the bundle needs some way to tell Flutter that it's doing work. And I'm not sure what the standard mechanism is for doing that. Flutter thinks there's no more operations that need to be done. That's why it's moving on to render the image. And we can probably prove that by doing this. Well, this might be tied in to the Flutter tester as well, now that I think about it. What's a way to jump ahead? Let's do something really silly here. Still no image. Again, pump and settle should already be done on our behalf. Let's come back here to core, load image. Let's see, what else can we do here? I don't know if we have any timing mechanism that's in our control here. If futures are not in our control, I guess we can try a timer. Maybe that'll work for us. Let's see, what do we want to do here? Let's go like 3 seconds. All right, well, this is a waste of all of our time. So I'm going to go figure this out. This is not related to processing stuff. This is just tedious, irritating Flutter taking over control of everything in tests problem. So I'm going to go figure out what the standard solution is to actually be able to do a series of operations in a test like this. But what's important to keep in mind is that, let's see, if we go back to the way this was and bring back the previous print statements. Actually, I was going to say it gives us the length, but we never even make it that far, do we? We know that the file exists. We don't get to the other end of this read as bytes because of the test, but almost certainly everything is fine except for being able to wait for this operation to complete. So I'm going to go figure that out and get that committed. With the ability to paint an image, we can make, so what we want to do in the next video is be able to query pixel colors as well as capture regions of the display. And the fact that we can draw an image and then get the color of a pixel, it's going to make it easier for us to make sure that we're doing the right thing. So that's why we did this first. In the next video, we'll continue with bitmap manipulation or in querying. We probably have 2 or 3 videos in that area, but then we should be able to get back to doing some coding challenges after that. So I'll see you in the next video.